so today we're going to talk about slope, okay? All things slope, and slope is so incredibly important whenever we're talking about linear equations. So, I've got this wonderful, beautiful graphic organizer. This is like one of my favorite graphic organizers that I use every single year. I can't take credit for making it because I didn't make it. Somebody else made it and I stole it, but that's okay. I didn't steal it, I paid for it. Anyway, okay, so slope. Okay, let's start with, we're not going to fill out all of these. We're not going to talk about rate of change. We'll fill out almost all of this, but we're not really, it's not going to be related to necessarily everything we talk about today, but it will be later on this week. So let's start here, okay? What slope tells us. Okay, so whenever I say slope, okay, what I'm talking about is I'm talking about a line, okay, so on a graph, a line, but even more what I'm talking about is I'm talking about the direction and the steepness of the line. So, slope, ultimately, guys, it's a number, okay, it's a number. So this one number that we're going to learn how to find today tells me on my line, it's going to tell me the direction and the steepness of the line. So there's kind of 4 different options for what direction the line could go. Okay, the line could be sloping up like this. It could be like an increasing line, or we call that kind of a positive slope. It could slope down. Okay, call it a decreasing line, a negative slope, okay? It could be just a straight horizontal line, okay? Or it could be a vertical line. So today we're going to learn how to find this number, and this one number will tell you which of these 4 lines your line is going to look like, okay? Now, let's say it is sloping up or sloping down. That one number also is going to tell you how steep that line is going to be. So it could be just like barely sloping up, okay? It could be maybe a little bit steeper, or it could be like almost a straight vertical line, and it could also go the opposite direction, okay? One number is going to tell me if your line slopes up, down, is horizontal or vertical, and it's also going to tell you if it slopes up or down, how steep it's going to be, that one number, okay? So let's talk about how we're going to find that one number. Okay, here's how we are going to find that one number, that slope, okay? Slope is a ratio, and if you remember from chapter 2, okay, a ratio is a comparison between 2 numbers, okay? Now, I will tell you that I teach slope a little differently than I'm sure Miss Dieters did last year, and probably differently than almost every other teacher does, but I teach it this way because I think my way is easier and simpler and easier to understand. So how I teach slope, and actually, guys, it's the same thing Miss Dieters taught you last year, it's just different words. And I'll show you what I mean by that whenever we actually find it. But here's how you're going to find slope. Slope is a ratio between the change in y, that triangle means change in y over change in x. Change in y over change in x. Change in y, that triangle just means change. Change in y over change in x. Now, depending on what information we're given, we may use this idea of change in y over change in x, or sometimes today you're going to be given an actual graph. So you're going to be looking at a line in order to see what the slope is going to be. And if that's the case, if you're actually looking at a line, this should seem familiar. We can also find slope by doing rise over run. Does that sound familiar? Rise is going to be the vertical change, and run is going to be the horizontal change. Now, before we even move forward, though, these actually, although they're different words, they're actually saying the same thing, because the change in y, if you think about your y-axis, this is the x-axis, this is the y-axis. So if I'm talking about the vertical change, guys, that is the change in y, okay? And over the run, or your change in x, that is the horizontal change, okay? It's the same thing, just saying it different ways, okay? Yes? Vertical change over horizontal change. Vertical changeable is all change. Okay. The next box we're going to fill up, we're not really going to use today, but it will be relevant tomorrow. We're going to go up here to the top, okay? Another way you can find slope, and like I said, we're not going to be using this today, but we will use it tomorrow, is if you have an equation, okay? So these two ways down here are if you have maybe points or if you have the actual graph. But if you're just given the equation and you want to find the slope given an equation, this is like the easiest way to find slope, because all you have to do is you have to make sure your line is in the form y equals mx plus b. Should hopefully sound semi-familiar. Okay? And you can find slope very, very easily, okay? Now here's the thing. Your equation isn't actually going to say y equals mx plus b. You're going to see the x and the y, but you're not going to see the letters m and b, okay? There's going to be numbers there. So it might say something like y equals 1/2 x minus 3. So the x and the y are there, but the m and the b are going to be replaced with numbers, okay? Because the m, like in this equation, the number in front of the x, okay, this one is 1/2. Do you guys remember what the m is? That's your slope. So you know that number that I've been talking about, how we're going to try to find today? Slope. If you're given the equation, you just look at the equation and I say, oh look, my slope's 1/2. It's that easy, okay? The b, in this case, the -3, this is the y-intercept. The y-intercept. So we'll talk more about this tomorrow and Wednesday. But basically what this is, on your y-axis, this is where your line crosses your y-axis, okay? So we're just going to we'll write that down, we'll kind of leave that there for now. We're not really going to worry a whole lot about that today, okay? Now let's move over and let's actually start finding slope. So this is what you're going to be doing today, kind of, in a way, okay? If you're given a whole entire table, which you're not going to be given this today, this is a great way to kind of introduce how we find slope, okay? What this is, okay, is I'm given, let's start with this vertical table right here, okay? So with this table right here, I've got 4 points, and they're not written as an x, comma y, kind of written as a table. So what this means, I've got -4, -2. So if you were to plot the point -4, -2, okay, you can put a point there. And then you plot -2, -1, and then you did 0, 0, and then 2, 1. If you were to plot all 4 of those points, they'd create a line. What I'm looking for is the slope of this line. Well, how we're going to find slope of the line is this right here. To find the slope of the line, we're going to do change in y over change in x. Change in y over change in x. And here's how you're going to do this. You're going to look at your y values, and you're going to have to figure out, well, how are they changing? So my y values are -2 to -1, -1 to 0, and 1 to 0. And it's kind of like a pattern. What's that pattern from -2 to -1, -1 to 0? You're adding 1 each time, right? So my change in y is +1. And then you're going to do the exact same thing with the change in x. So, from -4 to -2, -2 to 0, 0 to 2, once again, it's kind of like a pattern. What's that change? +2. Excellent. +2. So, the change in x is +2. So, your slope, +1 over +2, your slope is just 1/2. So, here's the thing. Since your slope is positive, it's a positive 1/2, this line would slope up. Okay, now 1/2, in terms of slope, it's not a really big number. So what this tells me, because I'm a little more familiar with slope than you probably are, it's going to slope up, but it's not going to be a super steep line because it's not a very big number. Okay, that's what that one number tells me, is I can kind of already get an idea of what this line looks like. It's going to slope up, but not very steeply. Okay, and then let's say we want to do this one over here. Okay, slope is always change in y over change in x. Okay, we're going to be saying that a lot today, change in y over change in x. You have to do the change in y first, okay? This time, though, my slope, my change in y is 0 to -3, negative 3 to negative 6, negative 6 to negative 9. What's that change? What is it? Now, are we going in the positive direction? We're going in the negative. We're subtracting 3 each time. Your change in y is minus 3. And then you're changing x from 7 to 11, 11 to 15, 15 to 19, plus 4. So negative 3 over a positive 4 would be a slope of negative 3/4. So this time, guys, since it's negative, without even graphing these 4 points, I can tell you that if you were to graph these 4 points and connect a line, it would slope down. I already know that. I also know 3/4 is a little bit bigger than 1/2. So this line would slope down steeper than this line would slope up. That one number tells you that. Okay? Now, we're not going to be given a whole entire table today. What you're going to be given today is either a graph or you're just going to be given 2 points. Because what we're going to find out on Wednesday, and that you already know whether you remember it or not, you only need 2 points to make a line. Okay? So if I have 2 points, I could make a line, which means I could find the slope of the line between those 2 points. So let's try a couple of these. Let's say I have the 2 points, 0, 4, and 6, 12. 0, 4, and 6, 12. Now here's the great news. We find the slope between 2 points the exact same way we found slope in that table. You are still going to take change in y over change in x. The only difference is it's not in a table form, it's just 2 points. So to find the change in y, you're just looking between 2 points, not between 4 of them. So you have to look, remember these are in the form x comma y, x comma y. So to find the change in y, you're going to go from 4 to 12. The first y coordinate to the second y coordinate. Well, now here's the thing. First of all, it has to be addition or subtraction. So now you can do times 3, but we're not using multiplication. We have to use addition or subtraction. So how do you get from 4 to 12? Plus 8. Plus 8. And yeah, and it's good to do distance and direction. So a plus or a minus, okay? And then the change in x from 0 to 6, plus 6. Okay, now, slope, yes, it's a ratio, but it's also a fraction. So you need to make sure your answer is in simplest form. So I wouldn't want to leave it as 8 over 6. I would want to reduce this to 4 over 3. Now, we do not want to change it into a mixed number because slope is a ratio, and a ratio is a comparison between 2 numbers. Okay, so you want to leave it as an improper fraction. Okay, now I mentioned that I teach slope differently than you were probably taught last year. So what I wanted to do is I want to show you how you were probably taught last year. And guys, if this isn't really clicking with you and I show you what you guys did last year, like, oh, I remember that, that was easy, I want to do that instead, that's fine. As long as it makes sense and you get the right answer, I don't care which way you find slope. Just know that I'm going to do change in y over change in x. In my years of experience, students tend to have more success with change in y over change in x because I think it's simpler and I think it's easier to understand. But, like I said, if you want to use the method you learned last year, that's fine. So the method you learned last year was using a formula. And the formula said to find m, which is your slope, you're going to take y2 minus y1 over x2 minus x1. You guys remember doing that? Okay. So if I wanted to use this formula, and maybe I want to find the slope between, let's squeeze this one up here, between the points negative 2, 7 and 2, negative 1. Now the idea of using this formula is super simple. You're just going to plug in, sorry, this is negative 2, 7. I know it's not, it's kind of squeezed in the negative 2, 7, 2, negative 1. So the idea is really simple. You're just going to plug in y2, y1, x2, x1, and you're going to simplify. The idea is super simple, but it can get kind of tricky with the subtractions and the negatives, so you have to be very careful. Now, where you get these y2 and y1, x2, and x1 from is the points. The first point is going to be x1, y1. The second point is going to be x2, y2. So to find the slope, you're going to take y2, which is negative 1, minus y1, which is 7, over, and then you do the same thing with your x's. Now, here's where you have to be really, really careful, because x2 is 2, but then you have to take minus, here's where it gets tricky, x1 is negative 2. So you have to minus a negative 2. Okay, so be very careful. So, negative 1 minus 7 is negative 8. 2 minus a negative 2, we keep change, and it'd actually be 2 plus a positive 2, which would be 4. And negative 8 over 4 gives me a slope of negative 2. Now, just to show you that I think my way is easier, if instead I did change in y over change in x, for the change in y from 7 to negative 1, and you really kind of have to picture a number line here, but if you were to start at 7 on a number line and get to negative 1, 7 all the way to negative 1 would be minus 8. There we go. And then the change in x from negative 2 to a positive 2, going from negative to positive would be a positive, right? Plus. And from negative 2 to a positive 2 would be 4. Negative 8 over 4. Okay, so I think the change in y over change in x is easier, but if you like the y2 minus y1 over x2 minus x1, I'm not going to say you can't use it. Okay? All right, last thing we're going to talk about down here, which is going to be a little more relevant whenever we get to Wednesday, but it's kind of good to start thinking about these things, are the 4 different types of slope that we've kind of already talked about. Okay? Now, the first type of slope, okay, is going to be a positive slope. A positive slope, okay? A positive slope is going to be a diagonal line. And we've kind of already seen this a little bit, I kind of mentioned it, that if you have a positive slope, your line's going to look like it's going uphill. And we always read a line going from left to right, just like you read a book, okay? Now, whenever we look at an equation, which, once again, we're going to get more to this tomorrow and on Wednesday, remember the slope is the number in front of x. That's what we talked about up here, okay? So what you're going to see in the equation is that number in front of x is going to be positive. So it might be something like y equals 3x minus 1. Or maybe y equals 1/4 x plus 2. Okay, but the number in front of x is going to be positive. But one important thing to notice is these equations have an x and a y. Okay, if you look at these, they have an x and a y. Okay, we'll see kind of why that's important whenever we get to these last two. Okay, so we could have a positive slope or we could have a negative slope. Now, a negative slope is also going to be a diagonal line, but this time when you read it left to right, it's going to look like it's sloping downhill. So if you were to roll a ball down it, right, the ball would be rolling downhill, okay? Now, these equations are going to look similar to the positive slope, except the number in front of x, it's going to be negative. So maybe it'll be like y equals negative 5x plus 1, or y equals negative 1/2 x. If that number in front of x is negative, it would be a negative sloping line. Now these equations, if you notice, they also have an x and a y. Okay, most of your lines are either going to be positive or negative, but sometimes you could have a line, and we saw this earlier, okay, that's going to be a horizontal line. Okay, it's going to look like this, a horizontal line. Now the slope of a horizontal line, and this is really important, okay, a horizontal line has a zero slope. Zero slope. Because kind of think about it, like if you were to read this left to right, think about your height, right? Your height is changing positively, right? You're going uphill. This, your height is changing negatively, going downhill. But if you were to walk along a flat surface, zero change in height. Okay, does that make sense? Another way to keep in mind with this, okay, because the next one, these are easy to confuse. A zero slope, the z has 0 slopes on it. Okay? Now, the equation of a 0 slope might look something like this. Y equals 3, or y equals -4. The equation of a 0 slope is a y-only equation. Now, these can be kind of hard to remember, and I understand why, okay, because what we're going to find out is the next one is just the opposite. So I have a way to help you remember. Okay, I have the 0 slope, right? We got the z on the 0, you got the 0 change, however you want to remember that, what it looks like. But how you can remember that the equation of a 0 slope is a y-only equation, okay? When I'm like, oh, you guys have homework tonight, you're like, why do you give us so much homework? Or you're like, why do I love math so much? What do you do with your arms when you say, why? That's it? Isn't that what a 0 slope looks like? So y, if you see an equation that's a y-only equation, and you need to think, okay, what does that graph look like? Think y. Okay, that's how you can remember that, okay? Now, the last type of slope, if you're kind of maybe guessing here, we have a diagonal, diagonal, horizontal. This is going to be a vertical line. Now, this type of slope, there's 2 ways you could call it. I like to call it an undefined slope, undefined. You could also call it no slope. It either has no slope or undefined. I prefer undefined. Now, here's the thing. You know how I said the 0 slope has like the zeros on it, or the 0 slopes on the z? An undefined slope has undefined slopes on the sides of the u's, which is kind of neat, okay? The equation of an undefined slope is going to be something like x equals -2, or maybe x equals 6. The equation of an undefined slope is going to be an x-only equation. And my way that you can remember this, if you have an equation that's an x-only, and you're like, what does that look like? Think x like an axe. What does an axe do? Right? X like an axe. Okay? Yeah? Okay, let's get this glued in and then let's look at some examples here. So, page 35, this is 5.1, slope of a line. Okay, so 2 things for your homework today, okay? First thing is going to be finding the slope of a line between 2 points, okay? And this is the main thing. This is like the main big point in the homework today, okay? So number 1, let's say we have these 2 points, 3, 2, and 1, 5. 3, 2, and 1, 5. So what I want to do is I want to decide, okay, if you were to graph these 2 points on a coordinate grid, okay, and if you were to connect them, what would the line look like? Okay, would it slope up? Would it slope down? Maybe it'd be horizontal, maybe it'd be vertical. Okay, you could actually graph it, or you could find the slope by doing change in y over change in x. Change in y over change in x. Now, a couple of very important things to remember, okay? First thing, it has to be change in y in the numerator. Second thing, be very careful to make sure you go from one y coordinate to the other y coordinates. Remember, the y coordinate is the second one. So you're going to go from 2 to 5. And what you're kind of looking at is you're thinking, okay, on a number line, if you were to start at 2 and get to 5, you need 2 things, direction and distance. So from 2 to 5, is that in the positive or negative direction? Positive. And then how many from 2 to 5? So you would add 3. So your change in y is plus 3. And then you do the same thing with the change in x from 3 to 1. Now remember, it's direction and distance. So from 3 to 1, what's that direction? You're going in the negative direction. And you're right, it's -2. So your slope, probably a better way to do your answer, a positive 3 over -2 would be a -3/2. This line would slope down. A -3/2, okay? It's bigger than 1, right? It's 1.5. This would slope down, I mean, a little bit steeper than some of the other ones that we talked about, okay? Number 2, let's say we have -1, 0, 3, comma, negative 2. Okay, same idea, right? If you were to plot these 2 points, what would the line look like? Would it go up or go down, and how steep would it be? So to do that, you do change in y, not change in x, messing up already, change in y over change in x. Okay, you have to do the change in y first, and when you do the change in y, make sure you go from one y coordinate to the other y coordinate. So the second point to the second point, okay? So from 0 to negative 2. Okay, first thing, direction from 0 to negative 2. Negative. And then how many from 0 to negative 2? So it's a minus 2. Okay, now, for your change in x, you're going from negative 1 to 3. So first of all, if you're going from negative 1 to a positive 3, what direction is that? Positive. Okay? Now, anytime you're going from a negative to a positive or positive to a negative, I sometimes think it's kind of handy to maybe picture a number. You don't have to necessarily draw one, but maybe picture one, okay? So it's from 0, we've got negative 1, 2, 3, going to 3. So in your head, what I picture is I'm like, okay, from negative 1, I'm going to get to 0 first, right? Because that's 1, okay? And then from 0 to 3, I'm going to get to 3. So I kind of take a pit stop at 0 when I'm going from a negative to a positive or positive to a negative. So from negative 1 to 0 is 1, and then 0 to 3 is 3. So what's the distance there? 4 plus 4. Remember, so it's a fraction, so we want to make sure we reduce and write your answer in simplest form. So it would be a negative 1/2. Is this making sense? Okay, let's try a few more of these. Okay, number 3 says 4, 3, 1, negative 1. Okay, to find slope, we're doing change in y over change in x. Change in y over change in x. So for the y, from 3 to negative 1. Once again, I'm going from a positive to a negative, so maybe take a pit stop at 0. From 3 to 0 would be 3, and then 0 to negative 1 would be 1. What's the change, including distance and direction, from 3 to negative 1? Minus 4. And then your change in x, from 4 to 1. 4 to 1, what would it be? Minus 3. Okay, now here's the thing. We want to make sure we reduce our answer. 4 over 3, I can't reduce that, I don't have anything in common. You do not want to change it to 1 1/3. You want to leave this 4 over 3, but there's one thing you can do to make this simpler. I have a negative over a negative. What kind of answer is a negative divided by a negative? A positive. The best way to write your answer, the simplest form to write your answer would be a positive 4 over 3. Okay, number 4. Negative 2, 3, negative 4, 7. Okay, slope is change in y over change in x. So my change in y, make sure you go from one y coordinate to the other y coordinate, from 3 to 7. What's that change from 3 to 7? 4 plus 4. Okay, now, these ones can be kind of tricky because I'm going from negative 2 to negative 4. I'm going from a negative to a negative. So first thing, really think about a number line. If you're going from negative 2 to a negative 4, what direction is that? Negative, right? You're getting smaller. And from a negative 2 to a negative 4, how many is that? Just 2. So it's a minus 2. So 4 over negative 2 would be a negative 2. Okay, 2 more. These are kind of special cases-ish. Okay, number 5, negative 2, 6, negative 5, 6. Okay, change in y over change in x. Okay, the change in y from 6 to 6. 0, right? There is no change there, no change there. Okay? And then from negative 2 to a negative 5. -2 to -5. What's that change? -3, going in the negative direction, -3. Okay, now, 0 divided by anything is 0. This is a 0 slope. Okay, this is a 0 slope. This would be a horizontal line, right? Change. Okay. What about this one? What if we do 3, 2, 3, -1? Okay, slope is change in y over change in x. So my change in y from 2 to -1. Going from a positive to a negative, so it might be helpful to take this up at 0, from 2 to 0, 0 to -1. What's that change? -3. And then you're changing x from 3 to 3? 0. Now here's the thing. If you had your calculator out, and in your calculator you said -3 divided by 0, you know what will happen? Your calculator's going to blow up! Just kidding. It doesn't blow up. But it'll say like domain error or syntax error. It will not divide by 0 because you can't divide by 0. This is an undefined slope. Your calculator will not divide by 0. You can try it if you want. Okay, it will not divide by 0. This is a vertical line. This is an undefined slope. Okay? All right. Now, the last thing that you're going to be doing on your homework is finding slope based off if you have a graph. So let's draw. Sorry, this is number 7. Okay, let's draw a couple of graphs here. Okay. So I want you to put a point at -3, 1, -3, 1, and then a point at 2, 3. Do a little bit of graphing here. -3, 1, and 2, 3. Now there's kind of 2 options here to find the slope of this line. I mean, I could say, okay, it's -3, 1, and 2, 3. I could do change y or change x. But we don't have to do that. This is much easier to do because if you guys remember, slope is rise over run. That's another way to think about it. So instead of thinking change in y, which actually, guys, rise is change in y and run is change in x, just think, okay, if I were to start at this point and get to this point, you just have to ask yourself, how far do I have to rise to get up to that level? What's the rise here? How many? 2, right? You go up 2. And then the run, you just have to ask, okay, well, how far to the right or to the left? 1, 2, 3, 4, 5. Your slope is 2 bits. Okay, what if we do, let's do a point at -1, 3, and then 1, -1. -1, 3, and 1, -1. Okay, same thing. Slope is rise over run. Now this time, to get from this point to this point, how far do you have to rise? How far do you have to rise? 4, but what direction am I going? I'm going down. So this rise is at -4. You're going down. Now the run, I'm going right. 2, +2. So your slope, -4 over 2, would be -2.